At the outset, I would like to thank ICLA organizers and also the peer reviewers of my article for allowing me to share my reflection on the issue of the validity of imperative inference, my talk today. I would like to reflect upon the issue both philosophically and logically. As you know that imperative inference includes imperative sentences as they are different from declarative sentences. So, imperative sentences has been accepted by philosophers since long past, and especially we can name Aristotle where we get the practical syllogism, and after that the Stoics, they also make the distinction between the command sentences and the proposition. After that Leibniz, Hume and all that, and finally we get the theory of Ernst Mally where we for the first time get the principle of inheritance of obligation, as well as a proper system of formal system of command sentences. Now, my scheme is like this, and also I have to say that after Ernst Mally, the entailment relation between imperatives have been viewed by many philosophers. I can name some of them: Jürgensen, Ross, Segerberg, and also the Nicholas Rescher and many others. So, my talk will be depending on the system developed by Peter B. M. Branas of Wisconsin-Madison, and I would like to talk on the concept of validity, criterion of validity, definition of validity rather, and the definition includes a particular phrase called meriting endorsement. So, I will be talking on it, and the consequences and the equivalence theorem, inadequacy of the definition, and finally one reformulation. Now, in ordinary discourse, as I have said that command is a part of formal argumentative discourse. So, I will talk on commands. Command of any form, they are viewed as expressing a prescription as different from declarative sentences which are used to express description. So, I will depend on prescriptions mainly, but also as my theory is dependent upon a specific type of imperative argument, the third variety, cross species. So, it will include the description as well as the prescription. So, I will be talking on both. Pure imperative argument means both the premises and the conclusion are imperative. Mixed premise means the premise is a set of mixture, that is a description and prescription, and cross species means if the premise or the premises are declarative, then the conclusion will be prescriptive and vice versa. So, let me first start with a general definition of argument validity. You see this argument, this validity definition is applicable both in case of declarative argument and also in case of imperative argument. So, argument is valid exactly if necessarily every fact that sustains every premise of the argument also sustains the conclusion of the argument. Now, the validity of imperative argument as given, as given by V. M. Branas is like this: an argument is valid only if necessarily if its premises merit endorsement, then its conclusion merits endorsement. Now, meriting endorsement, as there are two kinds of proposition as I just said. So, in case of descriptive proposition, meriting endorsement means being supported by true proposition backed by some fact, and in the other case it is reason that favors satisfaction proposition over violation proposition. Now, propositions are in this system viewed as a sets, and a prescription you can see it is a set of three things: one, satisfaction, violation and avoidance. They form a partition, and given any two, the third one is the complement of the union of the rest. So, they are mutually exclusive and jointly exhaustive, and we can represent a prescription as an ordered pair having S and V as two members, and the context means the union of S and V, and avoidance means negation of S and V, and negation means the first member will be violation set, the second member will be the satisfaction set. Now, in case of conditional prescription, actually we have the hypothetical sentence, and in that case the antecedent is a condition and it is the context also. Now, in case of any negative prescription, do not help him. Satisfaction proposition is that you do not help him. Violation is you help him, and avoidance means you remain indifferent. In case of conjunction, there are two kinds, unconditional and conditional. In case of unconditional, satisfied, if both are satisfied, violated is one or both are violated, and avoidance means denial of all acquaintance. Here actually I differ from Granules, because Granules did not like to accept unconditional prescription as having 3 values. And in case of conditional, S and V being the same, A means the denial of the antecedent. Now in this way I am not going to the detail because it is not that essential, just to understand the satisfaction proposition and violation proposition. So in this case, in this way, disjunction and conditional prescription also can be defined. Now I come directly to the 3 consequences. The first consequence of the definition I have just given. It is that reason means favoring the satisfaction proposition over violation proposition. It is obviously, as I have said, and it is arguably asymmetric in nature. That is, when the particular argument is valid, that means it favors the satisfaction proposition over and above the violation proposition. Now the second one is that meriting. Yes. Okay.
Yeah. Can I see 16 again?
No, 16. Yes, of course. 16 means I try to say that as you have now you know what is satisfaction proposition and violation proposition. So I am skipping those slides containing disjunction and conditional, because that is not important. I want to say that only for my talk, what is satisfaction proposition is important, what is violation proposition is important. If the satisfaction proposition is favored over and above the violation proposition, then the argument is valid. Now the first consequence, as I have just said, that prescription meriting endorsement means it is the reason favoring the satisfaction proposition over the violation proposition. Now what does meriting endorsement mean? Now it can be viewed from 2 perspectives. Number 1, meriting endorsement will be interpreted as meriting endorsement jointly or separately. And from another perspective, meriting endorsement pro tanto or all things considered. I am coming one after the other. Now jointly means and separately. Jointly means if some fact, the same fact sustains both the prescription and the proposition. And separately means some fact sustains the prescription, some other fact sustains the proposition. In the second case, the fact may be the same, may be different. So if something merits endorsement jointly, then it automatically merits endorsement separately also. Now in this from this perspective, D2, as I have just mentioned, D2 may be interpreted either jointly or separately. So D2 may be identical with D2J or D2S. D2J means meriting endorsement jointly, and S means meriting endorsement separately. So according to Granules, D2 actually should be interpreted as D2J, not D2S. Why? He has given some examples. The first one I am not entering because it is not imperative argument, or none of the sentences are imperative. Now argument number 2, don't tell the truth, so you smiled. And argument number 3 also, if you find that in both the cases the premise set is an inconsistent set, and of course it is not two valued logic in that sense, but still here also it is reasonable to argue that from any set of inconsistent premises anything can follow. But according to Granules, in case of the argument 3, the second proposition has got the conclusive reasoning. Granules, according to Granules, that this second proposition here I get the conclusive reason to tell the truth, and the first proposition, as there is no mention of any conclusive or non-conclusive, we can at least think of it is backed by some non-conclusive reason. So these two are separate reasons, so meriting endorsement separately. But in spite of these two, there may be some very good reason for the conclusion being false. I may have any other reason for not smiling. So while it merits endorsement separately, the conclusion is not following. So D2S cannot be the interpretation of D2, so D2J. Now first of all, there are 2 points of worry. Number 1, as in the case of argument 3, So also in the case of argument 2 also we can easily argue in the same manner. Two premises as they are opposed to each other, they must be backed by two different reasons, and those two different reasons, as it is not mentioned whether they are conclusive or not, we can very well give the benefit of doubt that both are backed by non-conclusive reason. Then also I may have you may have enough reason not to smile. So it is not only that argument 3, argument 2 also can be used to discard D2S. But my main worry is that in case of D2, sorry, in case of D2J as being identical with D2, I can also give one counter example. This is the counter example, that feel good if you dance, therefore you feel good. You say the first premise is not imperative, second one is imperative. Now according to some other thinkers, of course the first is also imperative because one portion of it is imperative, feel good is imperative. So anyhow the argument has the imperative statements and the conclusion is not imperative. So it is a cross species argument. Now in this case you see, according to Granules, the first premise has the satisfaction proposition as dancing and feeling good. This is the satisfaction proposition of the first premise, and a part of which is also the satisfaction proposition of the second premise. So it is the application of meriting endorsement jointly, the same fact supporting the first premise and the second premise. But as there is no conclusive reason that can connect dancing with feeling good, I mean the first premise, the first hypothetical premise, there is no mention of the conclusive reason. So I may have any other good reason, you may have any other good reason not to feel good. So there is no necessary connection, there is no conclusive reason. As he is giving stress on conclusive reason and as it lacks any conclusive reason, so in spite of being having the meriting endorsement, joint application of meriting endorsement, the conclusion may not hold good. So it is not the D2J. Then the question is, what is it then? Because there are only two ways, either it is applicable jointly or separately. So I think that it depends on the context. In some cases, two different facts taken together may help us to come to the conclusion. In some other cases, the same fact or a part of which helps both the premises and it also sustains the conclusion also. So the identity I am denying. I am not saying that D2 is or not identical with DJ. I am just saying that the identity relation I cannot establish. In some cases it is the same as D2J, in some other cases it is the same as D2S. That is the first thing.
In some cases you deny the identity, what you say?
No, I am not denying, I am only denying that it is identical. Identical means excluding the other. If it is identical with D2J, it can never be identical with D2S. So now the point is that reason he is picking, it is not the ad hoc reason, it is the conclusive reason. So from that standpoint, he is actually distinguishing between two kinds of endorsement. One is pro tanto, the other is all things considered. Pro tanto means, and in that perspective again the D2 may be interpreted as D2P or D2A. D2P means argument is valid if the premises merit pro tanto endorsement, then the conclusion also merits pro tanto endorsement, and the same case as all things considered. Now all things considered means undefeated sustenance of the conclusion. So all things considered as distinct from pro tanto, it is only sustained by some fact. And as I have said that according in this theory, fact means in case of prescription, not in the case of descriptive proposition, a fact means an object or a state of affairs, but in case of prescriptive proposition, fact means reason. So which one is to be accepted, either D2P or D2A? Definitely D2A, because it speaks of the conclusive reason, and the earlier one speaks of mere fact that can be ad hoc reason also. So we can easily take it as D2A. Now if we take D2A, then we can formulate the earlier definition in this manner: a CSI argument is valid exactly if necessarily every fact that guarantees the declarative premise of the argument supports the imperative conclusion of the argument. Now you see there is a similarity with the first definition, initial definition we have started. Now this definition, in order to show the use of this definition, there is one equivalence theorem that is showing equivalence between descriptive argument and prescriptive argument in this manner. Now it means the cross spaces imperative argument from the proposition P to the prescription I prime is equivalent to the pure declarative argument from P to the proposition that some fact whose existence follows from P undefeatedly supports I prime. So here there is an equivalence, and the second one is the validity. That means P entails I prime exactly if P entails that the fact that P is true undefeatedly sustains or supports I prime. This is the equivalence theorem, which has 3 consequences. Now the first one is very trivial, that any set of impossible proposition or prescription can yield any prescription or proposition as the consequence. The second one is also trivial, because for any f, the argument from the proposition that f is a fact which undoubtedly supports I prime to the prescription I prime is valid. I have given one example there, that if the first premise is that the fact that you have sworn to tell the truth is an undefeated reason for you to tell the truth, therefore from this premise it definitely follows that tell the truth. So condition, if we find out some embedded assumption in the equivalence theorem. What is the assumption? The assumption is, if it is a fact that some reason undefeatedly supports a given prescription, then that fact undefeatedly supports the prescription. Now this necessary condition, that P entails that the conclusion is supported by the fact, and this assumption that if it is a fact that some reason undefeatedly supports I prime, then that fact undefeatedly supports I prime, taken together they yield the sufficient condition. You see, if P entails that some fact undefeatedly supports I prime, that is the conclusion, and this is the condition, necessary condition I have just said, along with the assumption. What is the assumption? Proposition that some fact undefeatedly supports I prime entails I prime. These two taken together by transitivity, P entails some fact dot dot, and that some fact dot dot entails I prime, therefore P entails I prime. Therefore if the assumption is true, P entails I prime, provided we take the necessary condition into consideration. Now Granules tries to point out that there are some examples of invalid argument. They are invalid because they have violated this necessary condition. What is the necessary condition? That P entails that some fact undefeatedly supports I prime. Now he has given some examples. I will refer to 2. He has given 3 examples. The third one I need not. Yes.
You have to sum up the agreement one more.
Yes, of course. The previous slide.
I said you have only 2 more minutes to sum up.
Oh, sorry. So there are 2 arguments. Argument 5 means you will tell the truth, so tell the truth. Argument 6 means the fact that you have sworn to tell the truth is a reason for you to tell the truth. In none of the arguments, the premise speaks of any undefeated reason according to Granules. So these are invalid. I am not entering to 7 because it has a comparison with 8. What is then the valid argument? According to him, the premise should be there is an undefeated reason for you to tell the truth, therefore tell the truth. This is the format of the valid argument. Now there are 2 observations, first of which I am not entering because I have not entered 7 and 8. But the second one is that if this is the case, then fact means undefeated reason, reason means favoring satisfaction proposition over violation proposition, then it is now difficult to prove the validity of this argument. Suppose this argument, first premise is dance, secondly, so you dance if it rains. Now if we take Granules' model, then there are 2 things. First of all, there is no mention of undefeated reason, and secondly, the satisfaction proposition of the first premise or the premise does not entail the satisfaction proposition of the conclusion, because the satisfaction proposition of the premise is mere dance performance and the conclusion is reigning and dance performance. So, definitely the first one is not entailing the second one. So, if we go by Granules' definition of D2, then this argument will become invalid. But my proposal is thus that there is no need to mention any sort of undefeated or defeated present. What happens in case of declarative argument? We try to find out whether there is a corresponding fact. Here also we have to find out the person who will be assessing the argument as valid or not. It is his duty to find out conclusive or non-conclusive reason. And secondly, the point is important that if it is the fact that satisfaction proposition is to entail the satisfaction proposition of the conclusion, then it will never be valid. Actually, the first one, the premise is the unconditional prescription. If unconditional prescription is satisfied, that is the comment is satisfied irrespective of any condition, then whatever condition you add, it does not matter. It is not the question of the principle of law of addition. I am not adding here just in case of two valued logic, because it will then stuck up with the Jorgensen's dilemma, original dilemma, that the premise, if the premise is post the letter, the conclusion is post the letter or burn it. If you apply two valued logic here, two valued laws of addition, it will be post the letter or burn it. It is impossible. So, here also it is not the question of the application of the principle of addition. The point is that from unconditional prescription, if it is once obeyed or satisfied, we can add anything. It is not the question of addition of the two valued logic. It follows that once it is obeyed, it is obeyed irrespective of any condition, reigning or not reigning. That is the point. So, my reformulation is this, that every fact that guarantees the prescriptive premise, it can be the reverse also if the premise is descriptive and the conclusion prescriptive. Every fact that guarantees the prescriptive premise is either the fact or constitutes a positive and essential element of the total undefeated reason in favor of the conclusion of the argument. And that is all I want to say. Thank you.
Validity, what is the significance of the term necessarily? I do not understand.
And exactly, if necessarily, of course necessarily, because valid means it must be whatever is valid, you know, that we can put, or we have learned from the other speakers also, there is one L before that. So, to make it clear, very precise, we can easily add the L, because validity definition, if once I get the definition of validity, I can easily add by the law of necessitation, I can use it.
Okay, so this is the title of my paper, and I'll just deal with some of the philosophical aspects of this, because it's an extremely complicated paper with lots of dependencies. So I'll just explain some parts of granularity and what proto-transitive rough sets are, and then go into the knowledge interpretation almost. I'll be jumping very fast. Okay, there's the abstract. Now, in rough sets, what we do is we deal with vague objects. It's a mathematical approach to vagueness, where we should at least have at least one approximation of objects, and this is usually represented by a unary operator. We may have more, and in the simplest case we have at least two, the lower and the upper approximation, and usually it is done within a set theoretic setting, but we can always generalize. And okay, and here what I do in the paper is I do rough set theory over what are called proto-transitive approximation spaces. This proto-transitive approximation, proto-transitive relations are essentially generalizations of transitive relations, and they are motivated both by application contexts and theoretical contexts. And using the semantics, I associated knowledge interpretation with it. Even for classical rough set theory over equivalent solutions, we have a knowledge interpretation associated. This was formulated by Pavlak in 1991 itself. And much progress, and for around 20 years, very little progress happened in the field as far as the knowledge interpretation part is concerned, though it has been used extensively in all other places. And recently I did a full algebraic semantics of the same, along with alternative measures for knowledge consistency. And there is other work by Professor Meher Chakraborty and others. So there also they proposed measures for knowledge consistency. Okay. And here I have said a lot more about my paper. And this particular paper can be found at Arxiv. That's the link. Okay. Okay, so first I'll deal with granules. I'll try to explain what granules are. They are essentially building blocks of a semantics in some sense. That's the most acceptable and general definition that's possible. And but we can identify at least three distinct trends. One is what can be termed the primitive granular computing paradigm. The other one is the classical granular computing paradigm, and the final one is the axiomatic approach, which is the version which I have developed. And in computer science, most people know about the classical granular computing paradigm, and this has been adapted to rough sets also. And yeah. And so granular rough set theory can be done in at least two ways. One is following the classical granular computing paradigm or the axiomatic approach. Okay, this primitive granular computing paradigm is what ordinary people do often. So that's what I mean by that. For example, available primary building materials affect the nature of dwellings, and this has happened all throughout history. And the original number of requirements may be very large, but these are often modified by the available primary building materials. So here what happens is the goal is modified by what is really available, by the available granules. While in the classical granular computing paradigm, we don't follow it. What we do is we have certain specific goals already, and given and if we can solve the problem at some level of precision, then it is done. That is the usual idea. While in the primitive granular computing paradigm, it is not that way. So for example, we have constructions like this in Scotland. So here, as you can see, they really can't change the size of the rocks which have been used. While in computer science, we don't do this. Okay. And this is a summary of what happens in the primitive granular computing paradigm. And here, of course, the concept of granules may be concrete or abstract, but I'm not going into that. Okay. Then I go into the classical granular computing paradigm, which can be traced to the paper of Moore and Shannon that goes to 1956. And I couldn't find any previous reference to a similar method where the granular computing paradigm was used. And of course, it's natural for fuzzy set theory and all, but it has its problems. Those are well known. And generally, they don't have good mathematical semantics associated. That's one big problem. It's always like you have an algorithm and you want to get your problem done. Yep. And in rough set theory, of course, the axiomatic approach is very recent. In fact, papers with explicit reference to multiple types of granules happened only after 2008. And some of the papers are mentioned there. There is one paper due to me on choice inclusive offset theory, where I use explicit granules, and then there are explicit granules used in algebraic approach to tolerance approximation spaces. Tolerance approximation space is simply a pair of including a set and a tolerance defined on it, and from that we generate the approximations. Okay. And the axiomatic approach is explained in this paper. This is the paper in which it's really developed. Okay, then I go to generalized transitive relations, and these are fairly simple. If suppose the composition of one relation with itself minus the diagonal is a subset of R, then we say it's weakly transitive. And if the composition is a subset of itself, then it is transitive, and it's proto-transitive if R intersection R inverse is transitive. Of course, we are dealing with binary relations on a set. And of course, you can form an infinite number of weakenings of transitivity, but there is no uniform approach to these in rough set theory as of now. So this is the first attempt to do something with proto-transitive relations. And obviously, proto-transitive does not imply reflexivity. Okay, and in general, we do rough set theory using information systems or more practical situations also. One way is you can directly get the approximations from the real world and then form a theory for it. The other way is you just get huge data tables or databases with which are essentially tables with decisions, and those are called information systems. And those information systems may be deterministic or non-deterministic. Deterministic means that the cells have single values essentially, and if within a cell you have multiple values, then it's called indeterministic. That's a simple way of saying what is written there. Okay. Okay. We just have a multi-value relation from the objects to the parse set of values. This AT is the set of attributes, O is the set of objects, VA is the set of values taken for each attribute. And this is basically a table. You are not speaking anything very complicated. Okay. And the inverse problem I did mention already. Okay. And from a indeterministic information system, we can get a tolerance relation this way. Think, yeah. If you take a subset of the attributes and then you define X is indiscernible from Y if and only if this, then you say that, then you get a tolerance. And this way you can get various other kinds of relations. And in particular, we can get proto-transitive relations also. And often they are missed in applications, and that's a problem. And here are more motivations for proto-transitivity. And here I am assuming reflexivity also. I'll formally define it in the next slide. Okay. Yeah, this I mentioned. First thing is we can get them from any kind of indeterministic information system. Okay. And definable approximations have not been investigated in closely related contexts. This is a theoretical problem. Okay. And even Galois connections for the conservative point-based approximations were also not known till recently. And so these are some theoretical problems, and we have more practical problems also. Okay. I just have 5 minutes, so I'll go very fast. Okay, here's an example. This is using Caste system. I have formed a, I think I'll just do the example and then stop. That will be easier. Okay. Now, caste system and religion are of course among the deep-seated evils of Indian society that often cut across socio-economic classes. Okay. And methods of data collection, when we can get data relating to this from the National Sample Survey style surveys or through intensive on the field studies. It's always better to do intensive field studies because with NSS style surveys you don't get good data. And for problems relating to those like studying inter and intra-caste relations, you can easily get proto-transitive relations from this kind of context. Suppose H is a set of castes and subcastes, this will form some kind of tree-like structure, not exactly a tree though. And you can define untouchability this way. This means that there is an asymmetric relation and okay, Y would be perceived as a lower caste relative X if this happens. So this interaction can be varied. And this is a proto-transitive relation. Okay. And this is the definition of proto-transitive, proto-approximation space. And here the granulation is the set of all granules. Here the granules are successor neighborhoods. That's what I use throughout the paper almost. And if X is an element, then the associated granules are these. And these are two basic approximations. This is the lower proto, this is the upper proto, and there are many more. And we have the pointwise ones. And what happens is the pointwise ones and the original ones are all different. Okay, and there is a relation between the different approximations defined. Okay. And then there is plenty of algebra related to this, which I am going to skip. And finally, I go to the knowledge interpretation. Yep. This is. Yeah, and what happens here is that individual granules are atomic. I did mention what granules, the successor neighborhoods are taken as granules. And what happens is individual granules are atomic units of knowledge, and this doesn't work here. Then maximal collections of granules subject to a concept of mutual independence are admissible concepts of knowledge. Even this doesn't work in proto-approximation spaces. But in usual rough set theory, this will definitely hold. And parts common to subcollections of maximal collections of granules are also knowledge. That also doesn't work here. This is because granules do not become definite. Definite means that the lower and upper approximations of the set are the same. Suppose AL is equal to AU is equal to A, then you know that A is definite. And granules are not definite here. That's one problem. And should we call them granules? That's another issue. But the way I do the in the axiomatic approach, we can definitely regard them as generalized granules, for which some of the minimal conditions hold. And so these are some of the essential features, and because of this, we need to include inexact objects to define knowledge in this kind of rough set theory. That's the essential conclusion I get, but it's because there are too many details there. And how many minutes? Okay. And okay, these are a few concluding remarks. So in this research, what I have developed a new general rough set theory of proto-transitive relations, the representation of rough objects. This is very important for getting the semantics. But in this paper, you won't find the semantics. The semantics is in a separate paper. And this is also important for the knowledge representation. That is what happens. And the knowledge interpretation of rough sets is also generalized to provide sensible knowledge interpretations across different semantic domains. In rough set theory, we always have multiple semantic domains. One is the classical semantic domain from which we can see everything. And in the rough set domain, we are dealing with the reasoning of the person who is experiencing the roughness. That is the simplest rough domain. We can define many other rough domains, but these two will always be. And this paves the way for possible semantics, measures, and logics of knowledge consistency. And algebraically, the semantics has very nice features. So these are all generalities, and we have also shown in concrete terms that granular knowledge interpretation and classical knowledge interpretation are different things. So that's the main conclusion of this short paper. Okay, thank you.
Okay, so very simple announcement. But before that, let me thank all of you for coming and making ICLA so widely participated by people from all over the world. Especially, I would like to thank the invited speakers. They gave some really excellent talks, and that's something which everybody has appreciated. I'd like to thank my colleagues on the program committee, and we had 35 submissions for this conference, and 15 appear in the proceedings, and we have had there's presentations of some of the other things. And I'd like to thank all the people who submitted papers, who came here, presented their papers. Thank you very much for coming. And finally, I would like to thank my colleagues in the institute, starting with the administration of IMSC. They really did a hell of a lot of background work, and beginning with the director downwards, everybody. And the volunteers whom you have seen all over the place running around doing things for us, and they've really completely taken the burden of the faculty. So that's something which I would really like to thank everybody for, and thank you all.
On behalf of us visitors, those of us who have come from faraway places, I would just like to say how absolutely wonderful and so unexpectedly wonderful this conference has been. I mean, I'm sure all of us have memories of, we've overeaten, I know, we've walked by the beach, we've gone to visit Malapurvam, the temples, we've done things. We have also met those from other disciplines, philosophers, computer scientists, mathematicians, and I know that the feeling I have had, and I'm sure all of us have had, is somebody is there whenever we have a problem, whenever we want something to happen, somebody is there ready to help us. And I don't know that I've ever come to a gathering where we have felt as welcome as this, and it is you and your colleagues and everyone here. And I know I speak for all of us who've come from far away. Thank you very, 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 very much.
Thank you. And at 5 p.m. we have the movie, The Blue Umbrella, for those of you who'd like to watch.